next we will have Dr. Vallad talking about squash mosaic virus. And I guess I should mention too that we have now finished with our aphid transmitted viruses and we are moving into our beetle transmitted virus.
Thank you. So I'm Gary Vallad. I'm a vegetable plant pathologist with the University of Florida Department of Plant Pathology, located down at the Gulf Coast Research and Education Center, just south of Tampa, Florida. We're going to talk a little bit about squash mosaic virus. So squash mosaic virus is a member of the family Cucurbit, genus Comovirus. It is a bipartite, positive single-stranded RNA virus that's actually encapsulated in stable isometric particles, 28 to 30 nanometers. Because it's a bipartite virus, it means that the two single strands of RNA are actually encapsulated in separate particles, which is kind of interesting. The virus infectivity can persist for 6 weeks in plant tissue at room temperature, so it's extremely stable. And also the virus particles themselves are highly immunogenic, which has actually helped a lot in regards to development of serological assays for testing. So the host range squash mosaic virus itself is pretty much naturally found, can naturally infect a number of cucurbit species, and some species within the Echinopotiaceae, such as lamb quarters or goosefoot. But experimentally can actually been found to be able to actually cause symptoms on over 15 plant species and 11 different genera. It is a seed-borne virus, and that is pretty much how it is moved long distance globally. Unlike other seed-borne viruses, though, that this virus actually locates within the embryo itself, so it makes it very difficult to try to surface disinfest the seed to remove the virus. It's also beetle transmitted, which actually accounts for a lot of in-field local movement, and it's also mechanically transmitted through practices in the field, such as cultivation, pruning, clothing, handling the plants, plant-to-plant touch. So this can be very problematic in the field, and especially in protected agriculture. Squash mosaic virus foliar symptoms are very similar to a lot of the potiviruses that Carrie Mock just presented. So you can get green vine banding, mosaic, mottle, blistering, ring spots, protrusions of veins on the leaf margins. You can get prominent innations or outgrowths, plant stunting. And interestingly, with some of these viruses, or some of viral infections, you can initially see very severe symptoms. Then as new growth occurs, the plant can actually start getting more moderate or minor symptom development. But it's important that even though the plant looks like it might be growing out of the virus, that plant is still infective. So this image up here kind of shows a little bit of that green leaf banding, some blistering, and this actually shows some of the circling or the ring spots development. Here's some better images, again showing that green banding, the blistering of the leaves, some of this protrusion of the leaf margins, or I would call fringing of the leaf margins as well. This is a great example of the mosaic symptoms on the leaf. Here's some additional symptoms, some examples as well. Again, that fringing or that along the margins of the leaf as well. Here you can see again that green banding, the mottling of the leaf here. And here's actually showing it on small seedlings developing, where you can again see that green banding on here and the fringing of the outer leaf and a little bit of blistering on this seedling as well. Squash mosaic virus also causes symptoms on fruit. They're extremely variable. And again, it can consist of chlorosis of the fruit, mottling, and also malformed fruit, as seen here up on the zucchini, the pumpkins here, squash here. And here's actually an example of a muskmelon where it caused the chlorosis, but also it prevented the netting from developing on the mature fruit. So beetle transmission, squash mosaic virus is primarily in North America transmitted by species within the genus Diabrotica and also Acalaminate. So in this case, it's spotted cucumber beetle and banded cucumber beetle, and also the northern corn rootworm beetle. There are other species that have been reported as well, and especially in Europe, I think it's a ladybird beetle that has been found to be one of the vectors. So squash mosaic virus acquisition can occur after 5 minutes of feeding, and the beetles can actually retain and actually continuously transmit the virus for up to 20 days. Basically, the virus itself persists in the regurgitation fluid and in hemolymph, but it does not actually multiply within the beetle itself. Also, all three of these beetles have broad host range and can also transmit other diseases such as bacterial wilt in cucurbits, which is a big problem. So two maps here, I'm actually showing a little bit of the distribution of the beetles. So throughout North America, all these beetle species are highly common. And if you look at the geographical distribution of squash mosaic virus, the virus itself was first reported in 1934 in California, and it's also where the seaborne nature was demonstrated in 1941. It probably explains why the virus itself is globally distributed throughout the world, and actually there's probably a lot of places here that's not showing up in this map that probably has been present or introduced at one point because of this, the ability for it to get into the seed. Of course, it was more problematic a number of years ago, but it's become less problematic just due to seed certification practices. But some studies have found that seed transmission rates can range anywhere from 0.14 to 10%, and even higher rates have been reported up to 94%. So again, kind of pointing out that the virus itself actually infects the seed embryo and is not present in the seed coat itself. So surface disinfectants themselves are very ineffective. So seed testing is very critical. Again, so squash mane virus, because it's highly immunogenic, people early on actually discovered that based on serological tests, they could actually divide it out into two different groups. So you can have squash mane mosaic virus 1 and squash mosaic virus 2 are often referred to as the melon strain or the squash strain. And basically what was found is that squash mosaic virus 1 or the melon strain caused severe symptoms on the melons, including watermelon, mild symptoms in squash, and could also be seed transmitted in pretty much all the cucurbit species. Whereas squash melon mosaic virus 2 seemed to be more severe on squash and pumpkin, was more mild in the melons, and basically was unable to infect watermelons, and seed transmission itself was only limited to squashes. So, but it's important to remember that, even though you can't rely on just the symptoms alone in regards to which host it was causing, because they have found in some studies that both groups can actually cause similar symptoms on both melon and squash varieties, just depending on the variety itself and also the environment. So for diagnostic purposes, again, very similar to a lot of the potiviruses that have been described already. We rely on serological and molecular techniques really to pin it down, and these are readily available through services through companies like ACDIA and also through state and county extension service diagnostic labs as well. Another technique that was commonly used in the past was through use of inclusion bodies. It's kind of a lost art form, but still can be effective, but it doesn't quite tell you exactly which virus it is. It's really important, again, because of the nature of this virus and the way it looks very similar to a lot of the other potiviruses that Carrie just went through and Caesar went through, is that it's very important to get a good, accurate diagnosis so you can actually use that to adjust your IPM practices. And also, it might actually also stimulate some seed supplier conversations as well. Quick comparison of squash mosaic virus versus some of the other potiviruses. Again, the big difference is that, again, the primary vector for squash mosaic virus is the cucumber beetle, and it is very key that the seaborne nature of this is very key in introducing it to new areas where it's typically not observed. Versus the other viruses themselves, is the big difference is that they are actually aphid vector. But it's very important for cucurbit production throughout the U.S. is that it's really common to find mixed infections with other vector viruses is quite common, and those symptoms can really be changed from those mixed infections. So again, testing is very critical. Squash mosaic virus management strategies include, of course, sourcing certified or doing virus tested, sourcing your seed from certified lots that have been tested for the virus, maintaining that lot traceability and quality insurance documentation. And not just for the seed. If you're actually purchasing transplants from a third party operation, making sure that they're sourcing their seed, that those lots of seed or transplants that you're getting, that they are also coming from a tested source as well. If you commonly have issues with cucumber beetles in your area, it's really important to plan early for beetle suppression by managing weeds, potential hosts along the field edges, and monitoring the plants at the seedling stage. It's very important to reduce volunteer cucurbits because they can act as a bridge for virus infections between seasons. Of course, scouting to prioritize, to look through the fields and field edges for the beetles and recognize early symptoms in the field, especially early in the season, because then you might be able to actually go in and rogue and remove those infected plants early on to help prevent the spread, subsequent spread. But just also keep in mind, because it is mechanically transmitted as well fairly easily, to make sure that you're careful about maintaining that sanitation, which is of course the other part of this, is managing your equipment and crew movement when you suspect that the virus is present in the field, to limit its movement to non-infected plants. And of course, at the post-harvest area is making sure that you ensure that there's a rapid destruction of residue that can help limit that carryover and volunteer host to subsequent seasons. So with that, I will end this with a list of references and look forward to answering your questions afterwards.
All right. Thank you, Dr. Vallad.